Okay, everybody. If you're listening, we're going to work on a some work here on the inverse trig functions here. So we're going to start off with a little bit of work with the inverse sine. So in example 1 here, I have a table here with some numbers, -1 and 1/2 √2/2. Okay. Now, these are the x values, and we're going to compute the y values, the inverse. Now, the key here, all we're doing is working backwards. Let's put a little graph here, just to kind of look at. Here's the sine wave. This is from -pi/2 to pi/2. And we're only going to look at the portion of the sine wave, which runs from -1 in the y direction up to +1. And the sine function has been restricted for between -pi to pi/2. It's domain restricted so that it remains a one-to-one function. And notice we don't lose any of the range values of the original sine function by doing this. So this is the restriction. Now, this is the sine function. The inverse sine, if you were to take all of the ordered pairs and reverse the x with the y, you would get a function that kind of looks like this. Okay, and let's just look at these endpoints here. This point here corresponds to this point here, which had coordinates pi/2, 1. Well, that point now becomes this one over here, whoops, which is 1 pi/2. And likewise, this point down here is -1, -pi/2. And we have all the in-between points in here. So -pi/2 to pi/2. And this is the x, and this is the y. So this is the inverse sine. Okay, a couple things about the inverse. Notice also, in case you haven't picked up on this, this does not mean 1 over the sine of x. Okay, so a special case where this notation, when used in conjunction with function notation, which is really what this is, special function notation for the sine function, special name, with that -1, just like what you would see if you had this notation with the inverse function, except we're not using f, we're using sin for the sine function. Now, so to complete this table, what we're asking is that you find this number. This is what we're trying to find. This is y. So we want to know, this says the same thing as this. The sine of y equals +1, +1. Okay, so you have to ask yourself what value of y, in other words, what angle, what value of t if you're on the unit circle, or however you want to view it, what value of y produces a value of 1 when you push it into the sine function? Well, that value is pi/2. So let's see. Now I know I started this with a -1 here. I'm just going to put a 1 in here to represent this problem that I'm working on here. And my answer is pi/2, because the sine of pi/2 is 1. Now we could also do the same thing over here. The sine of what number is -pi/2? Well, the sine of -pi/2 is -1. What angle gives a sine equal to 1/2? Well, the sine of pi/2 over 6. What about root 2 over 2? Well, that would be the sine of pi over 4. So that's all it is. And of course, there are many other numbers between these x values that I've chosen. This will be a continuous function, but we're just looking at the ones that we can do by hand. Any other numbers that you would not be special numbers like these that could be gotten from the unit circle, for instance, we'd have to use a calculator. Okay. Now I think there's one more number up there. I put a 0 in the table. The sign of 0 is 0. Okay, so I've just got a few here, and I could do more here. In fact, let's just do one here that's sort of an oddball. Let's do 0.8. Now that's one that's, since it's not recognizable as a special number, a special angle that is, we would have to use our calculators on this one. So if you go in and calculate, I'm going to pause here for a second. I'm just going to try to pull out that TI. Get that on there. Okay. Now, okay, I'm not sure if you're going to be able to see this, but I'm going to go ahead and put my numbers in here. I'm going to select the inverse sine of that. I need to make that a little bigger. And I'm gonna put in that 0.8 and enter that. Okay, so there's my number, 0.9273, we'll say. 0.9273. So that would be over here then. There we go. Okay, so there'll be some more examples on like this one. I'm going to call it quits here. Put some more